our channel and back to the tutorial for deep learning. Today I am going to discuss the important topic called DenseNet. Going to explain within span of 5 minutes here. So DenseNet, today we'll see what is DenseNet and why you need the DenseNet and how it will helpful in the role of or in the field of computer vision and so on. DenseNet. So what you can say means DenseNet is one of the familiar type of CNN or deep learning model, or also you can show is extension of CNN only. And also the need of DenseNet is there will be some drawbacks faced with the DenseNet 50 architecture. So to overcome only the DenseNet network started develop here. So before you have to know exactly what is DenseNet. DenseNet, that is densely connected convolutional neural network, is one of the familiar feed forward convolutional neural network, and its architecture that always links each layer to every other layer easily. And moreover, this allows the networks to enhance by reducing the features and also helpful to reduce the number of parameters and enhancing the gradient flow during the training also. And the primary motive using the DenseNet is avoid the drawbacks of CNN. That means there will be increasing or the number of skip connections and by reducing the preceding of future maps too. And architecture. So if you want to understand everything, we need some understanding about DenseNet here. So DenseNet generally introduce a concept called paradigm shift because of here connect each layer connect to another layer and also follow the structure of feed forward only. And moreover, compared to the traditional CNN where it have a single connection between the consecutive layers, but DenseNet helpful to ensure that here layer receives input from all the preceding layers and passes to output to all the relevant layers here. This is a example of DenseNet layer where let's consider input image of horse and where consists of a dense block 1, dense block 2 with the convolution and pooling support. At last prediction it find out the result, that is the predict the result, that is a horse, like that once give the training means. So here all the layers are connected here. This session we are seeing that the basic concept only. And dense block, here what are the dense block? These are the fundamental blocks of DenseNet architecture. Moreover, here the block consists of multiple convolutional layers only. If you know already about the convolutional layers, we can understand that session very easily here. And moreover, here layer with each dense block receive future map from all the preceding as a input only, and always support for the future reuse and propagation too. Here this is the one where it connected dense block 1 connected with another one, and again dense block 2 connected with another one, again dense block 3 is connected with the another one, and so on. And here within the dense block what happen means here the layer can receive the combined output for all the preceding layers as the input here. Moreover, let's assume that if a dense block has m layers and each layer may produce the k mutual paths here, where k is known as the growth rate. So in this DenseNet we are going to see the term called growth rate and transition layer 2. Here transition layer is one of the important layer where supports number of features here and consists of the things like batch normalization, one by one convolution, at last end with the average pooling here, where batch normalization always helpful to normalize the feature maps, and one by convolution also helpful to reduce the number of feature maps here. At last average pooling is there very important because it always downsample the spatial dimensions and helpful for the predicted output also. And growth rate just not only is one of the hyperparameter in the DenseNet. Moreover, it helpful to say about the number of feature maps because each layer in the dense block produces a large growth rate. That means more information is added with the each layer here. But the major drawback of DenseNet is computational cost. We end with the applications of this DenseNet or 2, and before that we see the variations. So there are a lot of variations in the DenseNet, that is called DenseNet 121 followed by DenseNet 169 followed by DenseNet 201, at last 264. Here the 121 stands for the number of layers, and here also 2. Here number of layers is there as I told now. Here the advantage of this variant using DenseNet 121 is 7.98 million here, where we utilize for general purpose image classification and object detection also. If you use the DenseNet 169, we can there will be a lot parameters like 14.15 million, and we can go for enhanced image recognition and medical image analysis too. And if you go for currently DenseNet 201 is playing major role in the field of medical and so on. Here consists of parameters of 20.01 millimeter, where it familiar for providing high accuracy and enhanced feature extraction also, and detail manner. Then Atlas 264 is there. Here it consists of 33.34 million parameters, and you can use for any complex visual task and so on. Applications. So once come to the DenseNet, there will be a lot of applications there based on your research or anything, and we can use place the DenseNet in the field of NLP and image classification and so on. And for DenseNet, since I again repeating, is one of the flexible architecture where applicable to a variety of computer vision applications, and it includes a feature classification, many things. If you consider about the object detection, here the item, sorry, if you take any photo and movies including automobiles, people and building, it will help you to classify the object, sorry, detect the object, where is the people, where is the building, where is the automobiles, and where is the movie information, like that. And if you go for medical image, it will help you to identify and categorize various type of cancers, lesions, and other anomalies too. And audio, so and audio, if we come to audio, category of audio, here voice recognition, production, and auditing also we can get it here. And image classifying, so image classifying, can say about the photos. So if you have photos in the various manner like wildlife, object, and settings, with the help of this DenseNet we can classify easily. At semantic, at last we have a good thing about the application is called, so application of DenseNet is semantic segmentation. If you consider semantic segmentation, where segment the pictures into distinct area, maybe a sky, building. If we take a building, we can see the background, foreground, and we can divide like a sky, building, and roads, and etc. I hope that you understand today what is DenseNet and why we need DenseNet, and what are the building blocks of DenseNet at last into the application of DenseNet. If you like the video, please subscribe and share with your friends. Thank you for watching the video. Thank you.